Hello students, we are solving the IB Math AHL past paper questions and currently we are solving the IB Math AHL May 2021 paper 2 time zone 2 past paper. And today we will be solving the last question, that is question number 12 of this paper, and you will be getting the links to all the previously solved questions of this paper and of the other papers in description area in form of playlist. So without any further delays, let us start solving question number 12. It contains a maximum mark of 21 and actually it has 6 subparts. I have brought in just the first two. I'll be bringing up the remaining subparts as we complete the solving the previous ones. Okay. So a function f is defined by f of x equal to arc sine of x square minus 1 over x square plus 1 where x is a real number. Subpart A says show that f is an even function. Even function. Okay, so actually, okay, let me write from here. For even function, if of minus x, if f of minus x equal to f of x, then we call this as an even function. Right. So let us see what is f of minus x. So f of minus x is equal to arc sine of minus x whole square minus 1 over minus x whole square plus 1, which is equal to minus x whole square is x square. Arc sine of x square minus 1 over x square plus 1, which is equal to f of x. Okay. So therefore, f of x is an even function. Okay. And now coming to subpart B, it is saying that by considering limits, and okay, I can just write shown. And subpart B, by considering limits, show that the graph of y equals f of x has a horizontal asymptote and state its equation. Okay, okay. So, when does a graph move towards the horizontal asymptote? When x equal to a very large, very huge positive number, very large positive number, or very large negative number. So if it is moving towards the right hand side, x values are extremely large positive numbers, and or x values are very small numbers, that is very large negative numbers. They are in fact not small numbers, but they are very large negative numbers. In those cases, the horizontal asymptotes they become effective. Means it may be possible that the graph is trying to move towards the horizontal asymptote for extending to positive infinity, but for extending to negative infinity, it is moving towards, the graph is moving towards positive infinity or negative infinity. It is not that every time it will be moving for both x equal to positive infinity and x equal to negative infinity, the graph will be moving towards the horizontal asymptote. It may be possible that for x tending to positive infinity, the graph is trying to reach or move towards the horizontal asymptote, and for the when x is tending towards negative infinity, it is moving towards the negative infinity. It can be anything, okay? So we have to take the limits x tends to positive infinity, x tends to negative infinity, and taking them separately because we do not know what will happen. So I can take limit x tends to positive infinity first of all, arc sine, and this is x square. Okay, let me write the question first of all. X square minus 1 over x square plus 1 equal to limit x tends to positive infinity. I'm dividing the numerator and the denominator by x square, okay? So this is, or rather it is 1, x square over x square is 1. 1 minus 1 over x square over x square is again 1. 1 plus 1 over x square, okay? So when x is a very large number, 1 over x square, the denominator is very large. So what will the fraction value become? It will be equal, almost equal to 0. So it is 1 minus a very small number over 1 plus a very small number, almost equal to 0. So this is arc sine of 1. Okay. 1 over 1 is 1. And what is arc sine of 1? It is pi by 2. So this is pi by 2. So let me take the negative infinity as well. Over x square plus 1. Again, I'll be dividing the numerator and the denominator by x square. One minus 1 over x square over 1 plus 1 over x square. And again, it will be, x is a very large negative number, but x square is a positive number. Whenever you square a negative number, it becomes positive. So x may be a very large negative number, then x square will be a positive number. Okay, it will be a very large positive number. So in any case, x square is a positive number, so 1 over, and x square is an extremely large number, so 1 over x square is almost equal to 0. So again, we are getting the same thing. It is arc sine of 1, which is equal to pi by 2. So therefore, we can write it over here. Therefore, y equals f of x has a horizontal asymptote And the equation is y equal to pi by 2. So this is y equals pi by 2. Horizontal asymptote. Okay. So we have solved the first two subparts of this question number 12. Let me bring in some more subparts. Okay. Subpart C. It has two more subparts. So the I is show that f dash x, that is the first derivative of f of x, is equal to 2x over square root of x squared times x squared plus 1 for x belonging to the set of real numbers and x is not equal to 0. And the f of x expression was this one, arc sine of x squared minus 1 over x squared plus 1. X is a real number. Okay. So I. We have to get the first derivative of f of x. So f dash x, it will be arc sine of, okay, let me write, I haven't in fact brought in the formula for the derivative of arc sine of x. So if y equals arc sine of x, then y dash equal to 1 over square root of 1 minus x squared. Okay, you will be getting in the formula booklet. And I have written this formula for you. Now we, instead of having arc sine of x, we are having arc sine of x squared minus 1 over x squared plus 1. Okay. So this will be 1 over, and it is 1 minus, in place of x squared, x, we will be writing this expression. So it is x squared minus 1 over x squared plus 1 whole square. Okay. Times, because it is not x, it is an expression. So we have to differentiate this expression as well. It is the chain rule. So I'll be using the quotient rule for this, for the derivative of this argument. Okay. So it is x squared plus 1 whole square and x squared plus 1 times the derivative of x squared minus 1 is 2x and minus x squared minus 1. The derivative of x squared plus 1 is again 2x. Okay. So this is equal to 1 over actually this can be written as x squared minus 1 whole square over x squared plus 1 whole square. Right. So, okay, let me write it separately so that you don't get confused. Okay. And this part is 2x cube plus 2x minus 2x cube plus 2x over x square plus 1 whole square. So this is 1 over, this one is x square plus 1 whole square minus x square minus 1 whole square over x square plus 1 whole square times, these two will be getting cancelled. So we have 4x over x square plus 1 whole square. Okay. So this is equal to x square plus 1 whole square, and this is within the roots. So if I take this outside the root, it will be just x square plus 1. And this will be going to the numerator, so I can write this as x square plus 1 over, there is the square root, and I'm using the a square minus b square formula over here, which will be equal to a plus b times a minus b. So a is x squared plus 1 and b is x squared minus 1. So a plus b will be x squared plus 1 plus x squared minus 1, and a minus b will be x squared plus 1 minus x squared plus 1. Okay, times 4x over x squared plus 1 whole square, and now I can cancel these two. Okay, and over here these two will get cancelled and these two will be getting cancelled, so it is 2x squared from this part and this is 2 from this part. So 2x squared times 2 is 4x squared, and it is a square root. So I can take out the x square as well, but since I am having square root of x square, so I will be just taking out 2. It is 4x square, square root of 4x square, but I will be just taking out 2 outside the square root and I'll be keeping the x square inside because it is given in that way. Okay, fine. So it will be 4x over 2 times square root of x square times x squared plus 1 which is equal to 2x over x squared plus 1, over square root of x squared times x squared plus 1. Okay, so we have shown this. Shown. Fine. Now coming to II, by using the expression for f dash x and the result for Result square root of x square equal to modulus of x, which will be a positive number. Show that f is decreasing for x less than 0. Now, okay, fine. So in place of square root of x square, we will be writing modulus of x. Okay, so f dash x is equal to, I'm just writing the expression, the previous expression once more, 2x over square root of x square times x square plus 1 and is equal to 2x over modulus of x times x square plus 1. Okay, so for x less than 0, numerator is less than 0. Okay, 2x, x is a negative number, so 2 times the negative number is a negative number, so the numerator is less than 0 or negative. Denominator is greater than 0 because x modulus of x is greater than or equal to 0 and x is not equal to 0, sorry. So I cannot include the equal to 0. Definitely I will not be including the greater equal to 0 part. So yes. X is not equal to 0 and x square plus 1 is greater than 0. Okay. Therefore, f dash x is less than 0 for x less than 0. Hence, f of x is decreasing for x less than 0. Okay. So we have got 9 marks. Okay, this part C contains 9 marks and we have got the full 9 marks. So let us move on to the next subpart, that is subpart D. Function g is defined by g of x equal to arc sine of x square minus 1 over x square plus 1, where x is a real number and x is greater than or equal to 0. I have brought in the expression for f of x given in this very question number 12. And you see over here, the expression is exactly the same, but over here, x can be any real number. But for g of x, x is a positive number or x equal to 0. That is the only difference. The domain is not the same, but the expression is exactly the same. Subpart D says find an expression for g inverse of x justifying your answer. What does that mean, justifying your answer? Let's see. And it contains 5 marks. So we will be writing y equals arc sine of x square minus 1 over x square plus 1, and we will be interchanging the x and y positions. So that is the usual custom actually. So this is x equal to arc sine of y square minus 1 over y square plus 1. Sorry, I should be writing arc sine. So it is not only the arc, but it is the arc sine. Fine. Okay. And now we have to make y the subject. So what do we do? This can be written as sine of x equal to y square minus 1 over y square plus 1. And we multiply both the sides by y square plus 1 to get sine x y square plus 1 equal to y square minus 1. And this is, I'm opening the brackets, so it is y square sine x plus sine x equal to y square minus 1. And what can be done? Okay, I can add 1 to both the sides and I can subtract y square sine x from both the sides. What I am trying to do is I want to get all the terms containing y on one side of the equal to sign and all the other terms to on the other side of the equal to sign. Okay, so I can write this as y square minus y square sine x equal to 1 plus sine x. Okay. Okay, fine. So this is y square 1 minus sine x equal to 1 plus sine x. So this is giving us the y square expression as 1 plus sine x over 1 minus sine x. Okay. So whenever we get y square and we have to take the square root, we are just confronted with a question that which sign will we be taking, the plus sign or the minus sign, because the square root will be having plus minus in front and we have to take one of them and reject the other. So will y be a positive number or a negative number? If y is a positive number, then we will be giving the positive sign, and if y is a negative number, then we will be taking the minus sign. Simple. So to know that, we have to come to this part. The domain, what is the domain of g of x? The domain of g of x is a real number, of course, but x is greater than or equal to 0. So the domain of the original function will be the range of the inverse function. Therefore, the range will be a positive number or equal to 0. Okay. So I can write because, okay. This gives us y value as positive square root of 1 plus sine x over 1 minus sine x. And now I can write the because part. Because the domain of g of x is the range of g inverse of x. Since domain is x is greater than or equal to 0. Domain means this one. The range, that is this one. Range is y is greater than or equal to 0. Okay. So this gives us the G inverse of x expression. One minus sine of x. Okay. Fine. So I can write this over here. 1 plus sine of x one minus sine of x. Okay. Now coming to subpart E. State the domain of G inverse of x and it is just containing a single mark. Fine, and the G inverse expression, we are having the G inverse expression. Well, we have the domain of G of x given, and if we know the range of G of x, we can find the domain of G inverse. Simple. And since the expression for G of x is given, we can try graphing this because it is paper 2. Okay. You can find just by looking at the denominator 1 minus sine x. X cannot be pi by 2. If x is pi by 2, sine pi by 2 will be equal to 1. 1 minus 1, the denominator will be equal to 0. So pi by 2 cannot be the value of x. That can be found. So, but in order to actually know what is the domain of G inverse, so I think the best option will be to graph G of x. Okay. If we graph G of x, then we will be knowing that what is the range of the G of x function. That will be the domain of G inverse of x function. Okay. So, fine. At graphs, okay. And this one is it is arc sine of x square, fine. Arc sine of x square minus 1 over x square plus 1. X square minus 1 over x square plus 1. Fine, so enter. And x is greater than or equal to 0, so I have to take only one part, not the negative part. And it is Windows settings. I'll be taking x minimum as 0. So I'm getting this graph. Okay. And it is just going like this. And do you remember what was there was an asymptote, horizontal asymptote of f of x. Do you remember that? Let me go to the first, I think it was the first, yeah. You see, y equals pi by 2, this was the horizontal asymptote of f of x function. Okay. So, I have to, I need this one. Okay. So, I think this is if I draw the y equals pi by 2, I'll be seeing that we do have a horizontal asymptote. So, let me get it. This is pi by 2. Pi divided by 2. Enter. You see, y equals pi by 2 is indeed the horizontal asymptote of this function. So, we have found the upper y value. Y cannot be equal to pi by 2. Equal to, y should be less than pi by 2. And that we have seen from the expression as well, because sine pi by 2 gives a denominator value equal to 0, which we cannot have. But what about this lower value? For this, let us take the graph trace. Graph trace. And this is the y-axis. So if we take, if you want, I can enter. First of all, let me get it. This is the x. If x equal to 0, then the y value is this. But let me take this as from -1, so that you can see. You see, this is the y-axis. X equal to 0 and this. But the upper limit is pi by 2 and this one is minus a decimal number. Is it pi by 2? Let us try. Let us give it a try. So because pi is 3.14159 and so on. So half of that. So let us try. So pi divided by 2, 1.5708. Okay, this is the same number that we are getting. So this one is negative pi by 2. So y can have the value of negative pi by 2, but y cannot have the value of positive pi by 2. Okay. So, and it is just a 1 mark, so we do not have to explain anything. This is the range of the g of x function. So this will be the domain of the g inverse x of g inverse x function. Okay. It should be from negative pi by 2 to pi by 2. Negative pi by 2 will be included, but positive pi by 2 should be excluded. So the domain, it is subpart E, domain of G inverse of X is X greater than or equal to negative pi by 2, but less than pi by 2, because pi by 2 is the asymptote. We cannot, for the G inverse of X, pi by 2 will be the vertical asymptote. So X will be between negative pi by 2 to positive pi by 2. Pi by 2, this positive pi by 2 is not included, but the negative pi by 2 is included. Okay. So let me just rewrite over here. Okay. So this is the answer for subpart E, and we are having the final subpart, that is the subpart F, where we have to sketch the G inverse of X function. I am bringing in that question. Okay. So subpart F, sketch the graph of y equals G inverse of X, clearly indicating any asymptotes with their equations and stating the values of any axis intercepts. Asymptotes and axis intercepts means it can be the y-intercept or the x-intercept. Okay, fine. And the G inverse X expression was found in subpart D. This was the expression, and the domain of G inverse of X was found in subpart E. And for the range of G inverse of X, this is the domain of G of X. So the range will be y belongs to the set of real numbers and y is greater than or equal to 0. Okay, so this is the range of G inverse of X. Now that we know the function expression, we know the domain, we know the range, we are in a position to get the graph. We will be basically copying. We'll be finding the graph shape, from the calculator and we will be just copying, but we have to copy properly because it is containing 3 marks. Okay, so let us move on to the calculator. This is the graph. So we will be just typing in the expression. Fine. So this is 1 plus sine of x over 1 minus sine of x. Enter. Fine. And now we have to take the proper domain. So domain and range. So settings. It is minus pi by 2 to pi by 2. So negative pi divided by 2, and this one is positive pi divided by 2, and y is greater than or equal to 0. So this is 0 and okay. Fine. Fine. So okay, what is this point? So let us see. Trace, graph trace. Okay, we have got the y-intercept 0, 1. Let us write the points. Okay, so one point will be 0, 1. And of course, the vertical asymptote has to be x equal to pi by 2, because you see when x equal to pi by 2, sine pi by 2 is 1, 1 minus 1 will be giving the value of 0 for the denominator, which we cannot have. So this will be the vertical asymptote. And what about y equals, x equal to negative pi by 2? So negative pi by 2 is over here. Okay, so let me just type in negative pi by 2. Negative pi divided by 2. Enter. Okay. So this is negative 1.5708 and 0. It is the x-intercept. That was the y-intercept. This is the x-intercept. And negative 1.5708. What is that? If I want to, okay, let me take another calculator. It is, if I take negative pi divided by 2, it is negative 1.5708. Why did I take this? Because this side is having the vertical asymptote as pi by 2, and it is having the x is between negative pi by 2 to positive pi by 2. So, and this is negative pi by 2 is also written. Only confusing part is this negative 1.5708. So I just wanted to confirm, because negative pi by 2 is already written over here. Okay, and you know the domain is from negative pi by 2 to positive pi by 2, and we have taken the domain as negative pi by 2 to positive pi by 2. So, but over here we are having this confusing number, a decimal number. So if you want to confirm, you can just do negative pi by 2 and you will be getting the decimal value as negative 1.5708. So this one is another point. It is the x-intercept. So it will be negative pi by 2, comma 0. And if you see what, if you put negative pi by 2 for x, sine of negative pi by 2 is negative sine of pi by 2, which is negative 1, and negative of negative 1 is positive 1. So it is equal to 1 plus 1 is 2. The denominator is 2, but the numerator is sine of negative pi by 2 is negative sine of pi by 2. So the numerator is equal to 0. Hence, square root of 0 is 0. So you are getting the y value as 0. Okay. So whatever we have got in the graph has to be correct. But even then, this is just for a double check. Okay, so we have got these, and now we have to sketch the graph. So, okay, so it is, let me take it like this. Yeah, and I can take another one. This one as, I can take this over here. Okay, so this one is the X line and this axis, and this one is the Y axis. And this is 0, 1 is the y-intercept, and they should be the x equal to pi by 2 should be the vertical asymptote. And what is the value of the pi by 2? It is 1.57, so almost equal to 1.6. So this is, if I take this as 1 and this one will be, so this can be taken as, maybe this can be taken as 1.6. It will be just an approximate thing. So you may be saying that this is not 1.6, it will be 1.7 definitely, or 1.75, but this is just an approximate sketch. Okay, so I'm just writing this as x equal to pi by 2. And it will be 1 and this one will be negative pi by 2 and 0. So this will be one of the points. This is, maybe this is negative pi by 2. So the graph will be like this. It will be, again I'm showing you, this is going up towards positive infinity. So it will be of this shape, moving up. Okay. But this side you don't put an arrow, because it is between negative pi by 2 to positive pi by 2. You should be careful about this. Don't put an arrow towards the left. Then you will be going wrong. So this is the graph of G inverse of X. Okay. And this is, I can write this as 1. Okay, I'm writing this as 1. Okay. Fine. So this is the graph. We have given the asymptote and we have given the axis intercepts as well. So this completes our question number 12, and I'm Nilanjana Sanyal. I tutor IB Math A, ASL and HL level students from inside India and outside India. And I'm starting my group online math tutoring sessions. Those will be small groups, obviously. And for the freshers who have just started the grade 11. Okay. So if you are interested, for the grade 12 people also, if you have some, if I see that I'm having a group of students who wants to do some particular chapters, because for the grade 12 students who will be having their examination in the month of May 2024, it will be too late for uh, making a new batch for them for the entire syllabus to be covered. I'll not be doing that. But if you want to do to miss some portion of the syllabus, then it's fine. Okay, but it is for the new students, it will be the whole thing, will be whole syllabus will be covered. And in case you are interested in joining my group online tutoring sessions, or you want to know more about these sessions. You may contact me. You are seeing my email ID, you are seeing my WhatsApp number getting displayed. So you may contact me for more details. Okay. And thank you for staying with me till the end. We meet again very soon and we start a new paper in our coming session. Till then, bye.